Hey guys, welcome to another session of Cassandra Learning, the series for software for non-technical people. So today we are going to see about the ASCII code. In the last session we saw about what is a software. We got an introduction to software, and we saw that software are programs that run on computer and are broadly classified as system software and application software. These software programs are created using programming languages, and the languages are either a low-level language or a high-level language, right? And a software, we saw about a software stack that showcases that how a language processing happens layer by layer. So there is a high-level language or English-like language which can be easily understood by human, and then it is converted to a low-level language which is not that much understandable by human, but are a set of instructions, low-level instructions, and then that is converted into machine language, which is ones and zeros, which is then sent to the hardware for interactions. In this entire software stack, we decided that our primary focus is going to be on developing application software using using some of the modern high-level languages, right? So on that note, we are going to see, we saw that we are converting every instruction of our high-level language into machine language, right? So we're going to see how they are converted in this session. That is where the ASCII come into place. We'll see about that. So let's start the session, guys. So today's topics will be what is ASCII, how is it coded. We are also going to see a code table, which is basically like any code table, like a periodic table in chemistry or something like that. And then are there any other coding standards? We are also going to see that. It's a very simple learning today. Okay, before getting into ASCII, we have to understand how a program works, right? So from the statement here, z equal to x plus y, which is a program statement or general mathematical statement in a higher level language, like how we do. So what we are trying to do here, we are trying to add two values, x and y, and then we are trying to store it in z, right? So now think about it as a statement. What if this statement, this higher level language statement is given to a computer? What is it going to do? Like I said, it is going to add, so the primary work it is going to do is, it is going to add x and y and then store it in z. But how does it understand the statement? So if I ask you, what is x plus y? How does our brain function? If I ask you what is x plus y, what will you answer? So you will first, let's not say x plus y. Let's put values to it, right? So what I'm asking you a question. What is 2 plus 3? Okay. So what will you say? You immediately will say 5. How? So what does your brain do in this period? So it takes, it understands what our question is. So first thing is, it will understand the instructions that you are giving. So you are asking what is, which means you are expecting an output. So that is the first thing it will understand. What is 2 plus 3? So the plus is basically another instruction which tells your brain to add two numbers, which is 2 and 3. So now there are two instructions. One is give me an output, add and give me an output. what should I add? 2 and 3. So instructions are add, give me an output. 2 and 3 are the data. So we have to differentiate. So each statement a computer similarly will differentiate between data and instructions. So here when I say z equal to x plus y, it will simply try to identify x and y and also z as data, and then equal to and plus as instructions. So here equal to is to assign. So the operation that is going to take part, that is going to take in equal to is assign, the plus is add, right. So each statement will be divided into data and instructions, and then the operation will be performed. So basically for a statement, for an instruction set, for a language to function properly, for a program to function properly, in general we need a set of data and a set of instructions to work. That understood, right? And then similarly when you say data, when you give computer like 2 plus 3, this 2 and 3 does not change. It is a constant value for the program. So whenever you run this particular statement, it is going to simply add 2 and 3 and store 5 in z. In the second statement, if you look at it, z equal to 2 plus 3, right? So here it is going to just add 2 and 3 always, and then it is going to store 5 in the z. Whereas here the x and y can be anything. While running the program, whatever value you give to x and y is going to add it, and it is going to get stored in the z. So that is the difference. So here 2 and 3 are constants, whereas x and y are variables, right. So what happens when a computer is asked to define a variable? It defines an empty memory space. It will allocate memory, and then at the runtime, while running the program, it will store the values that are required, or we will input the values that are required, which will then get stored in the variables. Whereas if I assign constants, it cannot, it will not change, and it will simply use the constants to add the values and store. So this is the difference between a constant and a variable. So everything happens in the memory. In the memory, as far as data is concerned, it can be a constant value, it can be a variable, and everything is allocated in the memory. Even your instruction sets are allocated in the memory, and only the process gets executed after everything is allocated. The data and instructions are allocated to your memory, that is temporary memory, RAM, and it will process it, and then it will give you the output. So that is how everything happens. So now for allocating your instruction set into memory, we already saw how your instructions are converted into binary, because in memory we can only store ones and zeros, right? As far as the machine is concerned, everything is ones and zero. So similarly in RAM also you can only store 1 0 1 0, etc. So now what we have to do is we have to convert our instruction to ones and zeros and store it in memory for loading into the processor and performing the execution. So the memory should be allocated for instruction, and then everything, the assembler, the compiler, interpreter, whatever that runs on the language, that transfers the high level instructions we give into ones and zeros and then allocate in memory. Now the second part is the data. How does a data get converted into ones and zeros? So the data can be, like I said, it can be a number, it can be a character, like A, B, C, D, or a statement like your name, a name constant, whatever, right? So all these things needs to be allocated in memory, and for that, and it has to be converted into ones and zeros, the machine language, before it is allocated into memory. So how do we convert our numbers and characters to be allocated in memory, right? So we use something called as a binary number system as far as numbers are concerned. So a binary number system will be helpful in converting a number, a decimal number that we use, into a binary number. So it's very simple. All we have to do is imagine we have only two numbers in our number system, 0, 1, 1. So in the regular number system, the decimal number system we have 10 numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then again we go back to 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, like that. We repeat. So we build upon that 10 digits, right? So similarly, assume there are only 2 digits. So that is a binary number system. Now what will happen? 0, 0, then 0, 1, and then that's it. We'll go to 1, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and then 1, 0, 0. So like this it will go. So we assume there are only 2 numbers. That is how we will code our number system, right? So typically our 2 will be 1, 0. We don't call it as 10, but we call it as 1, 0 in a binary number. So 3 will be 1, 1, 4 will be 1, 0, 0, like that. So we simply convert that into the numbers will be counted in binaries. But when it comes to characters like A, B, C, etc., and there are other things like special characters like symbols like plus, minus, star, slash, everything is there, right? Quotations, all those things. So these symbols, to represent these characters, we need a standard way of converting them into the binary numbers. So so the American Standard Code for Information Interchange, or ASCII, that is where it comes into place. So American Standard Code for Information. They devised a standard. The American Standards Bureau, they devised a standard, and then it is called as American Standard Code for Information Interchange, which is in short called ASCII. So how is it coded? Say for example, let us take the uppercase A. They assign a number 65 to it, and then they convert that 65 to binary, which is 0, which is a 8 digit 0, 1, 0, 0, 0, 0, 0, 1. So 65 is then converted to like a binary number in a normal fashion. So A's value will be this. Like this, we take 1 byte and try to assign 127 characters, which includes alphanumeric like 0 to 9. 0 to 9 text, like not the number value, the text value of 0 to 9. If you want to display a character 0 or 1, then it needs to be a character, right? So for that, similarly for uppercase alphabets, lowercase alphabets, all the symbols included 127 characters, I think, and apart from that there are other special symbols. So totally they had created a code for 255 characters, That is more than enough for a computer to operate with a basic English characters and number, alphanumerics. So this standard code is called American Standard Code for Information Interchange. So the capital A starts with 65, B 66, C 67, like that. And similarly, the lowercase starts with 97 and it moves on. So this is how the ASCII is coded, and here is the table. Like I said, if you go to 65, you can see capital A here, B, C, D, F, G, H, until 90, and then some special characters. Then 97, the lowercase starts, and then some special, some special characters. So totally we have 255 characters in the ASCII table. So you need not memorize all these things and all, it's just for your information. So just understand that how a character is represented and converted into machine language using binary, like a number, how it is directly converted into a binary equivalent. Are there other coding standards? Yes. Why? What is the requirement for other coding standards in today's world? Because English is not the only language the world is using. We have other languages. So instead of 1 byte, that is 8 bits, 8 ones and zeros for a character, we do 2 byte character set, or we also call it as MBCS, multi-byte character set. And we have something called as the Unicode, which includes all the languages of the character set of all the languages of the world, and it can accommodate, since it's 2 bytes, can accommodate up to 65,536 characters in it, which is more than enough for all the world records. And there is also something called as ASCII, which is an older, it used to be IBM mainframes native coding system, but nowadays Unicode is pretty much the standard for all the other language, and ASCII is the standard for English. It's a very basic function. Now in summary, what we saw today is like for a program to function, we not only need instructions but also data. So data also needs to be coded into machine language, because we saw how instructions are coded into machine language, converted into machine language using compilers, interpreters, and then assemblers, stuff like that. Similarly, data also needs to be coded into machine language, but since data are values, we need a standard way of coding it, and that is where ASCII comes into place. ASCII stands for American Standard Code for Information Interchange, which has defined standards in converting each and every character that is available in English and special characters to be coded into a binary number. And apart from ASCII, we also have another thing called as Unicode. It's a modern coding system, and which includes characters from a lot of other languages of the world. So to understand binary, how do we understand, how do we convert a number to a binary, is like here you can see how a number is converted to a binary in a simple way. So all you have to do is, in a simple way, all you have to do is repetitively divide the number by 2. Say for example, if you want to convert 65, divide 65 by 2, which is 32, and the remainder will be 1. Similarly, 32 by 2, 16, remainder 0. 16 by 2, 8, the remainder is 0. 8 by 2, 4, remainder 0. 4 by 2, 2, remainder 0. 2 by 2 is 1, remainder 0. Now you start from here 0, 1, 0, 0, 0, 0, 0, 1. That is your binary equivalent of 6. It's a simple way of converting easily a number into binary. Hope you enjoyed this session. If you have any questions, please don't hesitate to comment. Thank you for being part of the Cassandra learning, and have a great day. Bye bye. We'll see you in the next session. Good luck.